All right, this is the Chapter 10 review. What's weird about these first few problems is that they are different looking and easier than the ones we're used to, which is why you're probably stuck on them. 10.3.1, you'll notice it has a quadratic term. It has a linear term, but it does not have a constant, right? There's no regular number after this. It just equals 0. And I'm going to show you two different ways to think about this. One, you can think about it as r squared minus 7r plus 0 equals 0, right? The constant is 0. And if you do that, you can kind of solve it like you would normally. We know we need r times r to make r squared. And we need something here and here to multiply to 0. And we need whatever we put here and here to multiply with the r's so that they add to negative 7 r's in total. Well, if I'm multiplying to 0, I need 0 times something, right? So I'll do plus 0, minus 0. It really doesn't matter here. And of course, if I want to add to negative 7, well, negative 7 and 0 gets the job done. So this is our proper factorization. We get r times r is r squared. R times negative 7 gets us negative 7 r's. And then if we add 0 r's to that, it's still negative 7 r's. And then, of course, 0 times negative 7 gets us 0, so this works. And our answers are r equals 0 or r equals 7. Either of these plugged in, right? R equals 7 for either of these will get 0. R equals 0 for either of these will get 0. Either of these will work. Alternatively, you can think of it like this. Well, I have something times itself minus 7 times that number equals 0. I'm going to write it out like this because oftentimes I find students see this better for whatever reason. Do you see we have two things being multiplied minus two things being multiplied? Well, these must be the same, right? Anything minus itself is 0, so how do I make that the same? Well, if r is 7, it works. 7 times 7 minus 7 times 7 is 0. The other option is if r is 0. 0 times 0 is the same as 0 times anything. So those work. And I guess I'll show you a third way. Another way is to notice that both of these terms have an r in them. And so when there's a number here instead of nothing, right, that number is a constant. It doesn't have a variable. But since it's not there, I can just factor out an r from both and get this. And you'll notice that this is the same thing as this over here, right? R plus 0 is r, and there's r minus 7. Our answers are 0 and 7. So a couple different ways to look at that. Again, factoring out an r from both, or just using your brain. There's lots of ways to look at it. Now down here, things are a bit messier, and I think the first thing we want to do to make this easier on our brains is to rearrange this equation. So I'm going to use some properties of equality. I'm going to add x squared to both sides because negative x squared plus x squared is 0. And of course, in order to do that, I need to add x squared to the other side. When I do that, I'm going to combine these two like terms. Since I have x squared plus x squared, this is not x to the fourth. Remember, x to the fourth is x times x times x times x. I'm not multiplying 4 x's together. I'm adding 2 x squareds. And that's exactly what it becomes, 2x squareds. Also, to make this a little bit easier, I'm going to subtract 7 x's because this will make this 0. One of our goals should always be to have the equation equal 0. It makes life easier. Right, multiplying to 0 is pretty easy. So when I do this, that goes away, and of course I have to do this to both sides to keep the equation the same. 3x minus 7x's is just negative 4x's. And so here's our new problem, which isn't that hard to solve. You'll notice, like the last one, it doesn't have a constant term. And so we can factor it like we did above, or we can notice, you know what, there's some common factors for both of these. I'm going to factor out not just a 2 from both, but also an x. And what I'm left behind with is x. 2x times x is 2x squared. And then, of course, I'm left with a minus 2 because 2x times negative 2, when we distribute that, will get us back to negative 4x's. So here's our new problem. And because it equals 0, it's really easy. Something times something is 0. Well, I win if I can make one of these 0. If x is 0, this part becomes 0, and this part becomes negative 2. 0 times negative 2 is 0. Or I could do x is 2, because when I plug it in here, I get 4, which kind of sucks. But if I plug it in here, I get 0, right? 2 minus 2 is 0. So 0 times anything is 0. Here are our two possible answers. Now, down here, right here, hopefully you can just see the answer, but because you asked for this problem, you probably couldn't. But I'll point out that this just means 2 times something is 242. Well, what do you double to get 242? Well, this right here is the number you double to get 242. It's 121. And then the question becomes, what do you times by itself to get 121? Well, either positive 11 or negative 11. Either of those times themselves will get you 121, and that's what this is asking, right? T squared, what number do you times by itself to get 121? If you really wanted to, use some properties of equality here instead of just using your brain, you could divide every term by 2, and these 2's would become 1s. 1t squared is just t squared. 242 divided by 2 is 121. You'll notice we get the exact same thing, and if we root both terms, because you have to do it to every single term, or actually I should say the entire side, roots and squares go away, and you get t, and then when you root 121, the root of 121 could either be positive or negative 11. Honestly, my favorite way to solve this is just use your brain. You'll make a lot fewer mistakes. You won't do weird root stuff. When you feel like you need to root both sides in general, you should probably just use your brain. So that's 1031C, and then of course here's 1031B. So right here. And this is another case of, if you just use your brain, you can probably solve this in your head. But I will show you how you can arrange it to make it a little more comfortable. So first off, our quadratic term is negative. So I'm going to move that over by adding. It's now positive. If I subtract 16 over, I already have a minus 4 there. If I subtract 16, I get minus 20. And now this whole thing's 0. Instead of writing 0 on this side, I'm going to write 0 over here. So again, I just added that over and subtracted 16. I get this. And instead of making all this 0, I just wrote equals 0 here. So this is just asking us, what do you square and take away 20 from to get 0? In other words, we know y squared has to be 20, because only 20 minus 20 is going to get you 0. And there is no nice number to times by itself to get 20, right? 5 times 5, 25, that's too big. 4 times 4, 16, that's too small. So our answer is the positive or negative version of the root of 20. If you want to simplify that, you can. 20, of course, is the same thing as 4 times 5. And I chose 4 times 5 instead of 2 times 10 because I can actually root that 4. The root of 4 is 2. So that root of 4 becomes 2, and I'm still rooting 5, which doesn't come out nicely. So either this or this, the simplified version would be this. This would be the unsimplified version above it. Either of those work. And if you think about it, we could solve this problem without doing any of this just by looking. 16 minus something is negative 4. Well, clearly, this part right here has to be 20, right? 16 minus 20 gets us negative 4. So what do you square to get 20? This number. And then you can simplify, right? If you plug that in, it'll come out to 20. 16 minus 20 is negative 4. All right, so that's 1031, A, B, C, D. The next one a lot of you had trouble with was 1034 part C. And I think it's because it has a number in front of our quadratic term. These can be kind of tricky. However, if I rearrange this, hopefully you'll notice something. I'm going to subtract 70 from both sides to make this negative 70 equals 0. And now everything's nice in order. Forgot my square. There we go. Nice and in order. We have our quadratic, our linear, and our constant terms all together. Whenever you're solving a problem, you should always ask yourself, what do you notice? And hopefully here you notice everything's divisible by 2. If you didn't notice that, you could go about solving as normal, and that would totally work. You'd notice everything is divisible by 2 at the end. It wouldn't be as in simplest form. But dividing everything by 2 is going to allow us to solve this problem very simply. So 2 divided by 2 is 1, so we get 1r squared. That's why we did it. It's much easier to work with. This divides nicely as well. Negative 4 divided by 2 is negative 2, so we get negative 2r here. And negative 70 divided by 2 is going to come out to negative 35, so we get minus 35. 0 divided by anything is just 0, so here we are. This is the same equation as the above. It's just going to be easier to factor. We know we're going to need r times r to get r squared. And because that's a negative number, I know I need a plus and a minus. Well, what two numbers multiply to 35 and have a difference, because they're opposite signs, of negative 2? Well, how about negative 7 and positive 5, right? This will get us our negative 35 when these multiply. I'll get negative 7r's, 5r's, for a total of negative 2r's. So now that the problem looks like this, it's pretty easy to solve. either r equals -5 or r equals 7 will make this equal 0. Now, reminder real quick, if this is the first time you're seeing this, it's not that I plug in both at the same time. No, I'm saying if I plug in -5 for both r's here, this whole thing will equal 0. If I plug in -5 here, I get -12, -5 minus 7. So -12 is not what I want to see here, but because this becomes 0 when I plug it in, 0 times anything is 0, so this works. Same thing here, it's just when I plug in 7 here, I get 12, right? Don't like 12, but if I plug in 7 here, I get 0, and 12 times 0 is 0. So there are two possible answers, and we should have exactly 2 because, again, this is a quadratic, right? Power of 2 means we're going to have exactly 2 answers. So that was 10.3.4 part C. Part D is this one, and a lot of people are confused on this. And I think it's just because you guys didn't try to make this look like a problem you know how to solve. If we distribute, we're going to get x squared. That seems good, right? We can get it looking like that last problem we did. So let's do that. X times both terms here is going to come out to x squared, because that's x times x. And then it's going to be plus 10 times x, which is just 10x. Here, when we distribute the 10 to both terms, we get -100, because 10 times -10 is 100. And of course, it's going to come out negative. 10 times -x is going to be -10x's. When we rearrange this to get all of our terms on one side and 0 on the other, I'm going to add 100 and add 10x's. I'll end up with x squared, add 10 more x's over to make 20x's, and add 100 to get here. That gets us 0. If we try to factor this now, we'll get x times x, and we'll need numbers that multiply to 100. And when they multiply with the x's, add to a total of 20x's. Well, that's pretty easy. 10 and 10, right? Now, last problem, we said there would be exactly 2 answers if it's quadratic, and this definitely is. This is -10 for both, right? Either way, you get -10. We say that has a multiplicity of 2 because it counts twice. So it's technically 2 answers. And the reason these things have 2 answers, by the way, and we'll talk about this later when we start graphing, is that when you graph a quadratic, it's going to look like a parabola. And so most of the time, that parabola is going to have 2 different values on the x-axis that make this equal 0, right? This is -something, 0, and -something else, 0. Those are the numbers that make it equal 0. For this one right here, what that means is that we have a situation like this. Let's say this point right here is -10 on our x-axis. Let me extend that out. So let's say this is -10, right? So apparently -10 makes our equation equal 0. So -10, 0 should be on our graph, right? Well, that means that our parabola must be doing this. It doesn't dip down through the x-axis. It actually touches the x-axis exactly at -10 without dipping below it. And we call that our vertex, by the way, that lowest point. So our vertex here is definitely below the x-axis for the red one. The blue one, like this, would end up right there. So it dips down into the x-axis and dips back out at the exact same spot, so this counts twice. So normally we expect 2 different answers because it's going to dip down and then come back up somewhere else. This one comes up and goes down in the same spot. So it counts. That's 10.3.4 part D. The next one was 10.3.6, and this is similar to the last one, except it had some words. When you take those words and convert it to math, it's pretty easy to see what's going on here. We're going to get our x's together and solve, right? We're going to simplify this equation by moving everything to one side, have it equal 0, and a lot of our problems will go away. The original problem said something like, find out when this and this both equal each other, right? So I wrote down the equation. This equals this. I'm trying to find x's that make this equal each other. And to do that, I can do algebra, right? So if I subtract x squared from both sides, hopefully you notice what's going to happen here, right? I'm going to subtract x squared to make this 0. When I do so, I'll probably subtract it. Excuse me. I'll probably subtract it over here because they're like terms. I'll also subtract 19 x's to make this 0. And when I do that, I'll probably subtract it from here because they're both regular x's, right? Get my like terms together. And of course, I want to subtract 34 to make this 0 as well, so this entire side is 0. When I do that, I have to do it to the other side, and I'll probably do it here because 34 and 6 can be put together, right? They're like terms. And so what we end up with is a bunch of junk equaling 0. And that junk is x squared minus x squared. Well, that actually goes away, right? Anything minus itself is 0, so that's kind of nice. We're not even dealing with the quadratic now. 5x minus 19x's is negative 14x's. And then 6 minus 34, if we do that, we're going to get negative 28. So you'll notice that there won't be two answers that make these equations equal each other. There's only going to be one answer, right? There's only one way to make this equation true, and it's when x is negative 2. If I plug in negative 2 here, that's what makes this 28, right? And I know this part has to equal 28, so that when I take away 28, I get 0. So there's only one answer that works. Apparently, this is the one spot where they both agree. So you can think about these two equations being parabolas. Here's maybe the left side one, and here's maybe the right side one. And this is the kind of situation we're talking about, where there's going to be one spot where they agree. It's going to be negative 2 comma something. If you plug that into both of these, you'll find the appropriate y value that matches for them, right? Apparently they'll equal the same thing. And that's where they're going to intersect, one single spot. Of course, if they intersected at two spots, we'd have to have some kind of situation like this maybe. And that's just not the situation we have, because if you notice, we only get one answer. So it must be one of these. Again, we'll talk more about graphing later. It's just kind of fun to talk about as we go along. So that was 10.3.6. Here's 10.4.5. Things are getting pretty spicy. We're trying to simplify this root. Now notice this is not an equation. So we can't just like square both sides because there is no other side, right? That's not a valid technique. And whenever you feel the urge to square or root both sides, seriously consider doing something else. Most of the time, that's where good ideas go to die. But for this, we're just going to try and simplify this right here. And the way we're going to do that is going to take some time. So I'm going to pause the video now. I'll make a separate video for this, and then we'll finish up with our last few problems. We've got this, a giant word problem, and then 10.4.7, which is this weird-looking quadratic equation, and 10.4.9, which is kind of a weird-looking quadratic. And yes, this is a quadratic equation once you simplify things. So in order to not make this video any longer, we're just going to pause. And I'll be back with another one.